Okay, I did not repaste the chart that is in the middle of your notes page. I didn't want to waste the space on here. But if you need to review that, you can pause this video and kind of look over that chart. I went over all of those rules at the beginning of 5-1. So you can also go back and refer to that video. For now, again, if you need to kind of review those before I jump in, then you can pause and kind of look at them or go back to the 5-1 video. But I'm going to jump right in here with example 1. So you'll notice that both of these expressions have the same base. They both have a base that is 81, which means that when you're multiplying expressions with the same base, that we can add those exponents. So we're going to turn this into 81 to the 5/6 minus 1/3 or plus negative 1/3, however you want to do that. Now you can do this one of two ways. You can put 5/6 minus 1/3 in your calculator, which is exactly what I'm going to do. So we do, oh, I got a bit in the calculate here. So we're going to have 5/6 minus 1/3. And we get 1/2. So now I can go back and this is going to be equal to 81 to the 1/2. Now you should remember from section 1 that that 2 now becomes the index of our radical. And you guys should all know that the square root of 81 is 9. So this yucky expression is just another way to say 9. Now we are going to go on to example 1b. So this one, oh my goodness, they've made it a little more tricky. What I'm going to do first is work inside of my parentheses. So your quotient of powers property that's up there on your page says that we're going to take this top exponent and subtract the bottom from it. Now, if there's nothing written there, I've written in a little 1. So we're going to have x to the 1 minus 1/2, which gives us x to the 1/2. And then there's no y in the denominator, so that y cubed just stays where it is. And then we have our 2/3 on the outside. Now, if you look at the power of a power, we can now multiply that fraction that's on the outside by each of our exponents that's on the inside. So we're going to get x to the 1/2 to the 2/3 times y cubed to the 2/3. So we get x to the 1/2 to the 2/3. So we're going to multiply those. And y, I'm going to turn that 3 into 3/1 to the 2/3. So notice I changed those fractions. Now, again, remember you can always slow down or pause me if I'm going a little too fast. So kind of take in what we've done there. I've just multiplied these fractions because they're powers of a power. Now, I can reduce these fractions pretty easily in my head. If you're not comfortable doing that, you can always use your calculator. And I've encouraged all of you to download the Desmos graphing calculator onto your phone. So you should have that at your ready as well. So this becomes x to the 1/3. And this becomes y squared. So now we have x to the 1/3 y squared. Well, y squared is pretty. It stays like it is. And, okay, so we've got multiplication right here. So this is going to be, I'm going to put my y squared out front. I'm trying to go vertically down so I don't lose you guys. And then that x to the 1/3, I'm going to turn back into a radical so that our final answer looks like this. All right, I think I've got enough time on this video that we can go on to 2a because it's a pretty short one. How can we write this using the properties of exponents? Well, we know that we can rewrite this as a b to the 1/n, 1/n, and then a which will then become a to the 1 over n, and b to the 1 over n. I'm sorry I keep writing 2, you guys. It's habit. So then this becomes the nth root of a times the nth root of b. So this property you don't really have on your the front of your page, but you can break apart these rational exponents just like you can break apart whole number exponents. So if you have your same indice applied to both of those radicands, you can break it apart into 2 pieces like this. So now 2b is doing this with numbers. So what I'm going to do is I'm going to write the cube root of 16 times the cube root of x to the 5th, like that. Now I'm going to do factor trees, and I'm going to do these in different colors. So I have my 16 out here. And we're going to make that 4 and 4, 2, 2, 2, 2. Now recall that with that index of 3, we need a triple of 2's. So this is going to be a 2 on the outside and a cube root of 2 on the inside. Then with our x, this x to the 5th means that we have 5 x's out here that we are multiplying. 1, 2, 3, 4, 5. Again, if we take out a triple of x's out to the front, and we have 2 x's left over, which we're going to write as x squared. Okay, now we have essentially here 4 separate pieces, because this is 2 times the cube root of 2 times x times the cube root of x squared. We can now put our 2 and our x together out front, and then we can take our numbers that are under the same index and put them back together. So these are going to become the cube root of 2x squared. And this is what we call the reduced radical form of the expression. So the stuff under the radical and the stuff outside the radical are both in reduced form. I'm going to go ahead and try to do 3a on this. If I get cut off, we'll just start it over new on the next one. You guys are pretty good at following along. So with these, again, our indices are the same. So we can put the 16 and the 8 together under our radical sign. When I do my factor tree for 16 and my factor tree for 8, I get all this whole big line of 2's right here, right? Well, we know that with an index of 5, we need 5 2's. So there's 1, 2, 3, 4, 5 2's. So that 2 comes outside of our index. Then our leftover 2's, and there are 2 of them, we multiply together and put them back under our index, our radical sign, our index with an index of 5. So that the reduced radical form of this expression is just 2 5th root of 4, or 2 times the 5th root of 4. There's always an imaginary, invisible multiplication sign right there. So don't forget that. All right, we're going to put 3b and 3c into another video.